Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. Sampling. This lecture is the summary of sample statistics. An important advice for me and for everyone. We must be good to others. You can find the link of the math website in the description where you can find the soft copy of this lecture. Some important notations which are used in sampling. Mu. This means the true population mean, whereas mu cap means the unbiased estimate of population mean, and x bar means the sample mean. Sigma square means the true population variance, whereas sigma cap square means the unbiased estimate of population variance, and S square means the sample variance. These are two formulae of sample variance. And P cap means the unbiased estimate of population proportion. Point estimates. There are three formulae in point estimates. Number one, the sample proportion. This is the formula of sample proportion. And sample proportion is equal to unbiased estimate of population proportion. In this formula, this X means frequency of the requirement, and this NS means the sample size. Formula number two, mu cap. Mu cap means the unbiased estimate of population mean, and this is equal to sample mean, and this is the formula of sample mean. Number three, the unbiased estimate of population variance, and the formula of this is NS over NS minus 1 times the sample variance, S squared. This is the formula of sample variance, where this PS means the sample proportion. Well, three important questions before constructing confidence interval for mu. These are three questions. Number one, name of the population. We must know the population, whether it is normal or non-normal. Sigma square. We must know whether sigma square is known or unknown. And we must know the sample size, whether it is large or small. This chart or table is extremely important to understand the confidence interval for population mean mu. There are three cases, case A, case B and case C. In case C we have two separate cases, case 1 and case 2. Let's understand case A. In case A, the first thing, name of the population. Population is normal. Number 2, sigma square is known. And number 3, any size. So when population is normal and sigma square is known, means this thing, population is normal and sigma square is known. So when we have this situation, then sample size does not matter. Sample size could be either small or large. It could be anything. Because of these two things, the distribution of sample means is always normal. So when population is normal and sigma square is known, then sample size is irrelevant. Hence, population distribution of sample mean is always normal. We don't need to apply central limit theorem here. So according to this formula, this distribution, we can write the formula for Z. The formula for Z is x bar minus mu divided by square root of this thing. When you will take the square root of this, you will get sigma over under root ns. And the formula of confidence interval for this case is x bar plus minus z. These two things are fixed in all the confidence interval formula, x bar plus minus z. And this thing has come from here. When you will take the root of this, you will get sigma over under root ns divided by ns under root. So this is case A. And width of confidence interval. If you have to find width of this confidence interval, you just need to multiply this factor by 2. Case B. In case A, the population was normal, whereas in case B, the population is non-normal. So this is the difference between these two cases. This is the first difference. And the similarity is sigma square is known in both the cases. And here sample size is any size, but here sample size is large. Large means greater equal to 30. So if population is non-normal and sample size is large, then CLT is applied. This is the application of CLT. CLT is applied when population is non-normal and sample size is large. These are two conditions for CLT to be applied. So according to CLT, the distribution of x bar is approximately normal. Approximately, not perfectly. Here distribution of x bar is perfectly normal because population was normal and sigma square was known. But in this case, distribution of x bar is approximately normal. So according to this distribution, we can write the formula of z. The formula of z is x bar minus mu divided by under root of this. And the formula of confidence interval is same as in case A. X bar plus minus z is fixed for all types of cases, for all these 4 cases. See, this factor is same in all 4 cases. And this factor come from here. And the width of this confidence interval is same, 2 times this factor. Now case C1. In case C1, the population is normal. In case A, population was normal. Here sigma square is unknown, is not known. Here sigma square was known. So this is the difference between these 2 cases. And because of this difference, this is also different from this case. Here sample size could be anything, large or small, but here sample size must be large. So when population is normal and sigma square is not known and sample size is large, so because of these 3 things, see, the population is normal. Because of this thing, population is normal. And since population is normal, so distribution of x bar is perfectly normal. This is very important. This means perfectly normal. Perfectly normal. And here x bar is approximately normal because of CLT. Although population was not normal. Same is here. X bar is approximately normal because of CLT. So since population is perfectly normal, So the formula of confidence interval will be x bar plus minus z times under root of this thing. Now case C2, population is non-normal. In case B, population was non-normal. Sigma square is unknown, sigma square was known, sample size is large. C, because of these two things, CLT was applied. So because of these two things, CLT was applied here. And because of these two things, non-normal population and sigma and sample size is large, again CLT is applied. So CLT is always applied when population is non-normal and sample size is large. So this is the distribution of sample means. X bar is approximately normal. And this is the formula of the confidence interval for this case. X bar plus minus z is fixed, and this thing came from here. The under root of this thing is here. And this is the formula of the unbiased estimate of population variance. Here we use the standard deviation. And this is the formula of z for these two cases. This result is here. And this is the width of the confidence interval. This table is extremely important to understand and organize the formulas of confidence interval for population mean. The next thing, sample proportion. This is the formula of sample proportion. And this is the unbiased estimate of population proportion. And this is equal to sample proportion. X means frequency of requirement and NS means sample size. Well, for large sample size, for n greater or equal to 30, sample proportion, this PS, is approximately normal. And this is the mean of sample proportion, and this is the mean and this is the variance of sample proportion. And this is the formula of confidence interval for sample proportion. PS plus minus Z, and square root of this thing is here. When you will multiply this factor by 2, you will get the width for sample proportion. If you are working for probability of sample proportion, then always do continuity correction of plus minus 1 upon 2 NS. I discussed this thing in detail in my samplings lecture. Hope this lecture will help you to summarize the sample statistics of sampling. Good luck and Allah Hafiz.